If you listen to analysis about AI in both old and new media, you cannot escape predictions about the future of AI. Things like, think of what AI will be able to do in 5 or 10 years, or this is just the beginning. This strong belief in the exponential improvement of AI capabilities pertains to both optimistic and pessimistic scenarios. On the one hand, AI will supposedly be able to solve many of our problems and rid us of menial tasks. On the other hand, it will make us all redundant as workers and achieve general intelligence that may put us all at risk. The problem with these predictions is that they are mostly based on a very simplistic view of technology and society, which ignores how technologies usually advance and instead replaces it with certainty that never exists. In this video, I'm going to use a few historical examples to show you that there is nothing certain or most probable about these predictions about AI, and that the exponential advancement scenario is just one possibility amongst many. By doing so, I will argue for one of the pillars of science and technology studies, that of avoiding technological determinism. The last few years have seen several AI technologies mature. Machine learning, deep learning, and other techniques have been creating tools that bring about new possibilities and capture the imagination. That said, contemporary media discourse on AI mostly centers on large language models and generative AI. Indeed, there is no denying that this last wave of AI tools achieved something that was impossible just a few years back, namely the ability of LLMs to sound human-like and compose answers that often make sense, and the ability of generative AI to produce images, music, videos, and more, which seems useful to people. To be clear, none of these tools is perfect, but they do constitute a significant improvement in capabilities and people find them useful. This significant improvement, if one needs to describe it on a graph, can be shown as a sharp jump. Developers have been aspiring to develop similar tools for a long time, but the results were not good until recently, which explains this jump. For instance, developing a chatbot that seems human in its responses and produces answers that make sense has been a human aspiration for several decades now. Yet what is the snag? If we read or listen to commentators about AI, we are just at the beginning of this rapid advancement, and continued exponential rise is imminent, almost predetermined. Yet how can they be certain? On what do they base their assertions? Did they study how technologies advance? Of course they didn't. In fact, scholars who studied the history and sociology of technology overwhelmingly agree that it is impossible to predict how and at what pace a technology will advance, since technologies have many trajectories and are contingent upon many technological, social, economic, and political variables. The process of development may encounter many barriers, such as physical barriers, engineering barriers, social and political barriers, and fiscal barriers. These barriers tend to be unknown in advance and surface as the process of development progresses. Moreover, it is hard to know how much such barriers will play out and to what degree they will slow the development process. This makes predictions about the trajectory and pace of advancement a fool's errand. For instance, in the case of LLMs, we know the largest LLMs have practically run out of human data to analyze during model creation. This may be an engineering limitation on future improvements. Another such limitation may be that the AI data centers are consuming huge amounts of electricity and water, and are therefore provoking resistance from residents. This may be a social or political limitation. Then there's the fact that no LLM to date has proven to have a path to profitability and a sustainable business model. This may be a fiscal limitation. Such limitations may be overcome, but it is by no means certain that they will be, or that enough of them will be to produce an exponential rise in this technology. The most sobering way to understand how technologies actually advance is to look at past technologies. For the sake of consistency, all three examples will come from the field of mobility. Let's look at the car example first. After an initial phase in which experimental car models were produced, car companies settled on combustion engines with 4 inflatable wheels, gears, suspensions, and a protected seating area. This model of the car and the means to manufacture it were a huge technological advance and transformed mobility and our landscape. It fundamentally altered the way we traveled from one place to another and also changed our cities, suburbs, and countryside. Yet the rapid advance was short-lived, and afterwards improvements were only incremental. The improvements of engines, the addition of safety features, and the ability to make cars lighter and in different shapes. These were not revolutionary changes, but incremental changes. Even the jump to electric cars was not revolutionary, as it was preceded by the creation of hybrid cars, and in any case it took around 100 years to come about. Indeed, back when the car seemed to be progressing quickly, people imagined that by the 21st century we would already be driving flying cars, very similar to today's rapid advance view of AI. Yet the flying car has not yet arrived. Moving to aviation, we see a similar pattern: rapid advancement followed by slow incremental advancement. Yet in aviation, we may identify two such waves. The first wave of rapid advancements was the creation of the airworthy plane at the beginning of the 20th century. No doubt, another revolution in human mobility, yet afterwards a long period of incremental advance. Larger bodies, more durable wings, different shapes, better engines, ability to fly higher and farther, and the like. The next period of rapid advancement would be the shift to the jet engine in the mid-20th century. The jet engine was a true game changer, bringing about the civil and military aviation we know today. Yet again, after this second fast-paced stage, advancements went back to incrementalism. Larger fuselage, better engines, more distance. No revolutionary change. The shape of commercial airplanes stayed virtually the same as it was at the beginning of the jet age, more than half a century ago. Moreover, in the case of aviation, we can see that technologies can actually be rolled back, constituting a reverse of advancement. The ability to significantly reduce travel time has been an aspiration of aviation developers since the dawn of this industry. Once upon a time, this was promised to be the next civil aviation revolution by going faster than the speed of sound. Although this has proven technologically possible, it was curtailed by social and political factors as people refused to live with constant sonic booms overhead. Indeed, the Concorde, which was framed as the future of aviation as it could travel double the speed of sound, ended up being a failed experiment. Since it was only allowed to travel over oceans, its routes were very limited and its economic viability was reduced. This, combined with other factors, resulted in the fact that from 2004 until the present, you could not travel above the sound barrier commercially. The possibility, exemplified by the case of the Concorde, that advancement will not only plateau but actually reverse is being totally ignored by those predicting continued rapid AI advancement. Last, in space technologies and the ability to reach Earth orbit and beyond, we again see similar pattern. Rapid advancement in the 1950s and 1960s, followed by incremental advances. The next rapid advance was marked by the move to the space shuttle. Yet in historical view, it seems similar to the case of the Concorde, in which the technology functioned but then rolled back. In the case of the shuttle, it was mainly engineering problems and budgetary considerations that defeated this advancement, and by 2012, the shuttle was no more, leaving virtually the only way to get to orbit again by rockets. Rockets have continued advancing, but incrementally, including the ability to reuse, which took a long time to develop. What we learn from these examples is that rapid development is usually short-lived and is followed by incremental development with occasional reversals of course. During the rapid development phase and immediately after, it is easy to imagine that this phase will continue indefinitely, yet history teaches us otherwise. Commentators on AI are doing a disservice to their audiences when they pretend that the rapid advancement of AI is the only or even most likely outcome. Instead, they should state plainly that it isn't clear if this technology will continue to advance rapidly and that the future of technologies is unknown. This may be a worse soundbite than promising the future of AI is full of miracles, wonders, and dystopian realizations, but it is more realistic and honest.